going
Okay.
to the US or something like this. But
Okay.
we only have like 2 minutes to to talk, and then maybe we can go through your presentation after after 2 minutes of.
Sure. And so
Maybe only 1 minute even. So that's is it okay?
okay. Absolutely. So are we starting in about 45 minutes? Is that correct?
Yes, we are going to open the webinar now. I mean, we're going to open the Zoom link now. We're going to open the link now, but at 9 o'clock, but we're going to start at 9:30.
Okay.
So, is there any changes regarding the presentation?
I just added some things, some notations to the slides, but other than that, they're fine. But there have been no major changes.
No major changes then.
Yes. How do I share my screen? Oh, there we go. Got it. Got it right here. Okay.
Okay, this green.
Yep.
Can you please try to share your presentation now with us?
Sure. Here it is. Oh, let's see. Oh, files. Okay. This is a little different. Let's see. Whiteboard, iPhone. Microsoft Power. Okay. Wait a minute. Hold. Change mobile. Let's see. So normally I can just sort of click on it. Let me just see what we've got here. So desktop 1. All right, share. Okay. Allow Zoom to share your screen. Okay, hang on a minute. Okay. Let's see. Okay. Let's see. Privacy.
Yeah.
Let's see. Photos.
Kita urus waktu presentasi.
Camera.
Iya, cuma kamu mesti umumin, suruh mereka untuk itu. Kontennya gimana? Kontennya akan otomatis masuk nih. Maka nanti akan dia otomatis akan udah di-connect ke Google Drive.
Let me think here. Normally I can just share the screen and that's it. Let's see here. Let's see. Start webinar. Okay. Share screen.
Is it not working?
Let me take a look here. I just usually I use GoToWebinar, so let's see.
But maybe you can. Did you press this share screen options?
I did. I push share screen and it's giving me. Oh, let's see, files. It should do it.
Like PowerPoint as a virtual background, maybe. No?
Let's see. Let me just see here. Okay. Google Drive, Box, Microsoft SharePoint. I don't know what all this is. Open system preferences. All right. Let's see. General privacy. Okay. Let's see. Not the camera, contacts, reminders, photos. Full disk files and folders. Okay. Let's see. Bluetooth. Full disk. Okay. Files and folders. All right. Wait a minute.
Can we help you in some way? Let's
see. No, I'm just trying to figure out how to share my screen here. I just want to share I mean, it's up on my screen. I just can't. I don't know. It says security and privacy. I'm not really sure what I'm supposed to be checking on here. Is it just files and folders, or I don't know what I'm supposed to be giving access to.
But in your PowerPoint, is it in PowerPoint?
Yeah, it's in PowerPoint.
Okay, it's not in PDF.
So let's see. I'm glad we have time for this. Let's see how I figure this out. Okay. Privacy. Okay. All right. Let's see here. Oh, system preferences. Okay. Privacy. Okay. Okay. This is ridiculous. Okay. You're not seeing this, right?
No, not yet.
Is there a way to make me the presenter, or is that, how will that go?
Yeah, you're.
Okay.
Udah. So, itu nggak bisa ini Pak, apa PPT-nya itu nggak bisa muncul di screen. Kira-kira karena apa ya? Maybe if you try to
PPT-nya ada di kita.
Maybe Dr. Alex.
Yes.
Can you please send your newest presentation to us? Then maybe we will operate it from here. If
Okay.
Yeah, just as a backup, you know.
Okay. Yeah. Let's. So how do I send it to you? Just where should I send it?
Email to Herman. We will type it in chat.
Sorry, you'll send it to me. You'll email it to me. Okay.
Yes, we will type it in the chat.
Oh, in the chat. Okay.
Yeah.
All right. I'm not seeing. Okay. So other chat. Got it. Okay. Got it. Okay. Okay. Where do I see the chat? I just, oh, there we go. Wait a minute. Okay. Okay, share screen.
Maybe can you
Okay, who can share? Okay.
Can you try it again? Can you try again?
Sure. I'm just trying to see. Oh, wait a minute. It's in the, maybe I can move it to the Dropbox and try that. Let me try that. I'll move it to the Dropbox, see if I can open it from there.
Are you opening it from the PowerPoint program?
Yes, yes, I'm opening PowerPoint.
And when you press the green icon that says share screen.
Yeah, so when I hit share screen, it just says Dropbox. Well, here, let's see, basic. Desktop.
You use advanced.
Oh, use advanced. Okay, sounds good. I'll try
And
that.
use beta,
Okay.
PowerPoint, and filter background.
Oh, okay, got it. Okay.
Then you choose your files.
Got it. Okay. So let me see. Desktop. Hang on a minute. Webinar. Okay.
Yes.
Okay. Let's see. Open. But it says okay. 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 All right. There we go.
Wait, we didn't see it yet.
All right. Hang on a minute. Let's see if this is what we got. Okay. Do you see it?
Still blank. Wait.
Okay.
Oh, yes.
Okay, great. Lovely. All right. So now you see SARS-CoV-2 and COVID-19 variants, vaccines.
Yeah.
Okay. Wonderful. Okay. All right, great.
Emang kayak gini, Pak? Nggak apa-apa.
Ya, saya kan ya begini. Ini kamu bisa atur kamu punya. Ini kan bisa disisipkan. Okay, so you can try to click and see how it's moved.
Okay. Okay, I'm not, yeah, it's not moving. So, oh, I need to go to, let me go to, can I go to access slideshow?
Yeah.
Let me see here. All right. Let's see, let's close that. Let's see. All right. Nope. Okay. Meeting full screen. Okay. Let's see. Oh, I can do this.
Yeah.
You see it? You see it moving?
Yeah,
okay.
Yeah.
All right. I'll just do that. Okay. Do you want me to have my camera on, or I mean, do you need to see me, or what?
You can do because the audience will see your face only, so there is no disturbance on that. So
okay.
It's fine.
So I should just leave it. Okay. Sounds good.
Yeah.
Okay. All right. Thanks very much.
Yeah. No. Yeah, you can turn off your sharing this time.
Turn off what?
Sharing. The sharing, and then
stop share. Okay.
Yeah, stop share.
Okay.
So
and then
after it's your turn, then you can turn it on.
Okay. Sounds good.
That sounds good. Yeah.
But how do I get back to that? Oh, just with share screen again? Okay.
Yeah.
Let me just go through it again, just so I got it. Okay.
Okay.
It takes a while. Okay. All right. Now, so you want the slides off for now then?
Yes.
Oh, okay.
Because we will give you the opportunity to show your slide after this.
Okay. So will you start the webinar?
We are going to start at 9:30.
Right. Okay.
And so So, but we are going to open so our attendants can get in, and
Okay.
maybe they will, some will. Apa? Tunggunya nggak di dalam, di luar. Waiting room. Ya, udah di waiting room, di ada tulisannya kok. Nih.
Oh iya, ya Pak. Oh iya.
Kita buka jam 9.15 saja ya, 15 menit.
Iya, boleh Pak.
Munculin itu. Oke, kalau ini kamu munculin opening, share screen, yang opening. Yang atas. Ya. Oke, terus kita akan mulai jam 9.30 gitu aja. Kasih musik oke ya. Itu janjinya. Nah, kalau misalnya pakai MPD juga. Ya apa? Yang background. Background kelihatan dia. Ya. Apa-apa satu background.
Nanti aku ada di situ.
Tapi kamera ditutup.
Kalau
Lebih gampang buka tutup kamera. Nanti. Ya itu.
Okay, so just so I understand, we're going to start exactly at 9:30. You'll introduce me for a minute or so, and then sorry, and this will start at 9:30, and then at that point I'll share the slides. Is that correct? And then begin the talk.
Yes, but the thing is that I will, say something first in Bahasa, and then
Sure.
And then I will cue you by saying hi and good morning, Dr. Alex, and that's
Okay.
Yeah, and you can answer it.
Okay.
And then afterwards, you can start your presentation.
Very good. Thank you.
So when I say we are so excited to learn more about this topic and so on, and then I will welcome you to the stage. So.
Okay, sounds good. Thank you.
So how long is the presentation going to be?
Well, I'm going to hurry, and I'm trying to keep it under an hour. Is that okay?
Under an hour. Yeah, that's good.
Okay. So just so you know, I mean, I hope you saw the slides. So basically, just an introduction, sort of a map of what the maps for the involve the the present status of the pandemic, with maps and things like that, and that'll be short. And then we'll talk about vaccines, and then we'll talk about the variants, and then I'm going to really hurry through our slides about our product, GeneTex's products, and that'll be the last part, and then that'll be it. Okay.
Okay. But you mostly talk about the variants and also the vaccines, right?
Yes, vaccines first, and then variants, right?
I just want to update you that now Indonesia have a lot of Delta cases.
Delta cases.
Yes. Yeah, there's deltas everywhere. Deltas. I know it's predominant even in the UK right now. So I know it's and it's coming over. It's over in the United States also. So it's basically, I'll show maps on this. It's all over everywhere. What is it? So are you using what vaccines do you? I know Indonesia has several vaccines. What's the main one you're receiving? Are you receiving some of the Chinese vaccines? Are you receiving AstraZeneca? Are you receiving Pfizer, or what are you receiving?
Actually, right now we have several vaccines.
Right.
The majority is Sinovac from China.
Right.
And I would say the second will be right now AstraZeneca.
Okay.
And third, Sinopharm.
Yes.
Okay, so
Okay, so you have
that-
several vaccines, yeah.
yeah, actually, we accept all vaccine right now, including the how I call it, the Pfizer, but Pfizer, Moderna, we
Yes,
still cannot get any vaccine yet. So basically, right now we already vaccinated about 20 million something, more than 20 million.
what percentage is that of your population?
Yeah.
By population, I have to check in the internet. Let me send it to you. So maybe you have some
Okay.
fraction. Let me check. So in terms of percentage right now, we are for one dose is 8.1%.
8.1, so not
Yes,
less than 9%.
Yeah, 8.1.
Okay.
8.1. As of
Okay.
17 June.
Okay. 8.1%. Okay.
And full vaccinated about 4.4%.
Got it. Okay. Okay.
Sampai sini.
Habis itu tanda target.
Oke.
Terus habis itu dia
Oke.
ya. Terus setelah
Oh, enak. Okay. So that's the situation. Maybe right now there will be a lot of questions regarding the efficacy of the vaccine
Yeah.
due to different variant of viruses right now.
Yes. I know that for some of the Chinese vaccine, the Sinovac and the Sinopharm, they're waiting for more up-to-date information, right? I mean, they're waiting for some additional data, particularly for activity against some of the variants, correct?
Yeah.
Yes, you're right. You're right. So actually, maybe a lot of question regarding what the research happening in the US or in any part of the world. How the scientists see this and how they are going to solve the problem of different variants, right? So is there any general threat that can be targeted or what to make?
Well, yeah. I mean, I think that's the main question. I think probably the vast majority of the vaccines have effects against the different variants. There's more information, I think. I think there's, as I'll mention, there's some very recent data that's come out for Pfizer and Moderna, and also for AstraZeneca that, there's fairly good activity, certainly against the alpha, beta, and gamma variants. Delta is still pretty new. I mean, it really just came to sort of world attention because it was so dominant in India when India was having so many problems, and still is. But I think cases are starting to come down. But anyway, I think I think by and large, the vast majority of the vaccines seem to have activity against essentially all the variants. A little bit less in some cases. I think some of the vaccines from China might have a little less activity, but I think that more data needs to come out to really make that clear. The other issue is what will likely happen, and what I think is being discussed, is the issue of boosters. And I think all 4 vaccine platforms can certainly be modified. I think the Moderna and Pfizer, the mRNA vaccines, are probably the easiest to do that. But I would imagine that also the adenoviral vectors can also do that, where you can modify it and make a booster that's targeted to a certain variant. But I think they're still trying to decide, and the research still needs to determine what boosters will be needed to do that in a one schedule, whether it's every 6 or 12 months. And so I know that there was some concern over one of the vaccines with a CanSino vaccine that the immunity that it bestows lasts maybe about 6 months. And so people are now looking at it as maybe can be useful as a booster for some of the inactivated vaccines. So this is all being worked out. I mean, the vaccines are all really new, and the information is just sort of coming out as quickly as it can be released, you know?
Okay. I think we're going to open to start the webinar, but because we are going to start at 9:30, but we are going to open the how do you call it, waiting room.
Yeah.
Okay.
In 5 minutes.
Okay.
Yeah. So then we can wait until 9 to be started.
9:30, right?
Yeah, and 9:30. Sorry. Yeah. 9:30.
Yes.
Okay.
And can they hear me in the waiting room? Should I be quiet?
Yeah, it's better to be quiet.
Okay. All right. I'll close my big mouth. Okay.
No, you just turn it off. Your how I call it. You can mute your mic.
Oh.
Yeah, we cannot hear it.
Good, perfect. Okay. Kita buka aja kali. Ya udah tes. Arta. Coba kita tes video. Arta.
Ya, Pak.
Ya, coba tes video sekarang, coba.
Oke. Ya, bagus. Lancar. Suaranya jelas.
Oke.
Gambar oke.
Oke. Satu lagi. Punya si itu.
Iya, bagus. Bagus.
Hey, how are you? So, hi Ying. Oke, kalau gitu oke. Oke, thank you. Sekarang munculin di share itu dulu. Share ini dulu. Kita mulai jam 9:30 dulu. When I get here, I cannot go out.
Hi, Alex.
Hi, Ying. How are you doing?
Yeah, I'm good. But just
Okay.
due to the COVID case, so we have to stay at home on weekends.
Oh, well, I'm so sorry this is affecting your weekend, but anyway, I think I'm supposed to be quiet right now. So is everything good?
Okay. Yeah, everything good. So you already share your slides?
Yeah.
Okay.
We worked through that, so that I think we're up and ready here.
Okay, good.
Thanks, Ying.
Appreciate
it.
Bye.
Webinar. Oke.
Ternyata ada ribet banget deh.
Dia udah buka. Foto open ya. Share. Sudah berapa masuk? Di partisipan.
Selamat pagi semuanya. Assalamualaikum, Om Swastiastu, Namo Buddhaya, salam kebajikan dan salam sejahtera bagi kita semua. Kami, PT Biozatik Indonesia dan juga Jintex, mengucapkan terima kasih kepada para profesor, dokter, peneliti, serta Bapak dan Ibu sekalian yang sudah meluangkan waktunya untuk menghadiri acara webinar kami pada pagi hari ini. Webinar kami pada pagi hari ini bertemakan tentang update on SARS-CoV-2 variant research and the impact on vaccine efficacy, challenges for researchers and clinicians. Saya, Priscilla Natalia, akan memandu jalannya webinar pada pagi hari ini. Mohon izinkan saya untuk menyampaikan beberapa hal penting yang perlu diketahui selama webinar ini berlangsung. Yang pertama adalah, peserta wajib mengisi presensi melalui link yang ada di kolom chat maupun scan barcode yang akan ditampilkan di akhir acara. Dan yang kedua, data yang dimasukkan pada saat registrasi harus sama dengan data yang dimasukkan pada saat mengisi presensi serta feedback form. Dan yang ketiga, sertifikat hanya akan diberikan kepada para peserta yang sudah mengisi link daftar hadir serta feedback form dan mengikuti acara webinar ini sampai akhir. Dan yang keempat, sertifikat yang telah memenuhi persyaratan di atas akan kami kirimkan melalui email yang sudah terdaftar. Dan yang terakhir, kami himbau kepada para peserta agar tetap mengikuti acara webinar ini sampai akhir, karena akan ada pengundian hadiah untuk 12 orang yang beruntung. Kembali ke tema webinar kami pada pagi hari ini, pandemi COVID-19 telah menjadi momok bagi semua kalangan masyarakat. Dengan berita terbaru yang menunjukkan bahwa kasus infeksi masih terus meningkat, banyak dari kita yang berusaha untuk menjaga diri dengan mentaati protokol kesehatan, serta berusaha untuk mencari vaksin agar kita pun dapat melindungi diri dan keluarga kita yang kita cintai. Namun, apakah vaksin yang sudah ada saat ini mampu melindungi diri kita dari perkembangan mutasi COVID-19? Oleh sebab itu, di webinar kali ini, kita akan membahas tentang perkembangan COVID-19, mutasi-mutasi terbarunya, dan juga efek mutasi tersebut terhadap efikasi vaksin yang sudah ada di saat ini. Sebelum kita masuk ke topik utama, mari kita simak dahulu video perkenalan dari Jintex. Nah, setelah melihat video perkenalan dari Jintex, saya akan memperkenalkan pembicara kita pada pagi hari ini. Pembicara kita pada pagi hari ini adalah Dr. Alexander Bell. Beliau memperoleh gelar MD from University of Southern California School of Medicine. Dan saat ini, beliau menjabat sebagai senior scientist di Jintex. Dan beliau memegang peran penting sebagai penanggung jawab produksi serta validasi dari berbagai macam produk antibodi yang dikeluarkan oleh Jintex. Topik yang akan disampaikan beliau pada pagi hari ini adalah SARS-CoV-2 and COVID-19, variants, vaccine, and ongoing challenges for researchers and clinicians. Good morning, Dr. Alex.
Good morning. Thank you so much.
Thank you so much for your participation with us in this lovely Saturday morning. And how are you doing? And how is the COVID-19 situation going in the US?
Well, in the US, we're trying to increase our vaccination rate. It has slowed a little bit. We've had the unfortunate milestone of passing 600,000 deaths. But overall, the situation is improving. And as I'll talk about in my talk, the key is to get vaccines to all areas of the country.
Oh, I see. Okay. Yeah, therefore, we are so excited to be able to learn and to understand more about this topic from you. And if you are ready, then please, the time is yours, Dr. Alex.
Thank you so much. Give me just a moment to. Sorry for the delay. So thank you so much again for this opportunity to speak with you today. And thank you so much for the very kind introduction. What I'd like to talk about today is an overview of particularly vaccines and some of the SARS-CoV-2 variants. So there'll actually be 4 sections for today's talk. One is the present global situation, just a quick overview of where we are in the world. And then an overview of the different types of vaccines in which countries they're being distributed in and how they work. Then we'll talk a little bit about SARS-CoV-2 variants. I realize that in Indonesia right now, the Delta variant is a particular problem. And then after we talk about variants, for those of you who wish to stay, and I greatly appreciate people are taking their Saturday morning to listen to me today. But for the 4th section, we'll talk about GeneTex's SARS-CoV-2 product catalog for those of you interested in pursuing research against this virus. So the first thing is talking about the world situation. Where is the world in terms of cases, deaths, and hotspots where areas where cases are increasing? So at the present moment, from data from yesterday, the WHO, or World Health Organization, numbers are that we're just over 177 million cases of confirmed cases of COVID-19. And sadly, among that, well in excess of 3.8 million deaths. How are the number of cases, and this is shown in terms of weekly data, weekly case numbers, and how we look at it at different regions of the world. The Americas and Europe were richly or highly represented, but these cases are coming down as vaccines are distributed. In Southeast Asia, we've been seeing spikes, particularly India. I know Indonesia is dealing with its own challenges right now, but happily it looks like these cases in the Southeast Asia area are also starting to decrease. Eastern Mediterranean and Western Pacific are generally low, and an area that's also concerning is the continent of Africa, which is beginning to see a real uptick in cases in several countries. If we look at cases per capita, so the share of the population with a reported case, we still see that the United States is very highly represented, South America, Europe, and various countries in Africa, in Asia, and even in Russia. So it's still, there still are areas where particularly rich in cases per capita in terms of the number of cases. If we look at world deaths, we see that once again, overall deaths seem to be decreasing. certainly in the Americas and Europe, Southeast Asia, starting to come down. And at this point, African, at least based on this information, African deaths are still low. If we look at world case hotspots, we find that South America is definitely an area that's seeing a lot of cases. The southern part of the African continent, Mongolia, certain countries in Southeast Asia. These are all areas where cases have been increasing. And I think the point that will be the important feature of this talk is to understand that the key to this is vaccination. And that is really the point. As vaccines roll out more and more, the countries that have been successful at this, countries who have access to vaccines, will be seeing are seeing their cases and their deaths decrease. But we'll describe that a little bit more. So basically across the planet, there have been almost 180 million cases of COVID-19 with an excess of over 3.8 million deaths. Though cases and deaths have been decreasing in many countries, there are hotspots in various world regions. Spiking cases in these hotspots are likely due to more transmissible variants, little access to or compromised distribution of vaccines, some vaccine hesitancy, and economic and social reopening as the economies try to reopen. The countries most at risk suffer from economic challenges, lack of access to vaccines, and strained healthcare infrastructure. This was something that we saw all over the world. In the early part of the pandemic, certainly in China, and then certainly in the United States, certainly in Europe. And this is the case how it's been throughout all over the world as the pandemic has cycled through different regions of the planet. I understand that Indonesia is going through a particularly difficult time now with the Delta variant, as I said, with younger patients being affected, and that there's some of the problems that have been facing Indonesia are problems that have been facing every other country, and that is slow vaccine rollout, and not as many vaccines out there as you would like, not as much testing as would like to be done, and also the spread of variants. In Indonesia's case, that's largely the Delta variant. The most significant concern is that the spread of variants occurs more rapidly than the distribution of vaccines, and that significant numbers of people remain unvaccinated. That is really the main challenge. So let's actually take a look at some of the SARS-CoV-2 COVID-19 vaccines that are available in the world right now. This is data on the left. The tracing on your left shows the total doses administered, and this was data up through June 10th. And what it shows is that 2.3 billion doses of vaccine have been distributed over the planet. The problem is, pardon me, this translates to only about 30 doses per 100 people. And if we look at vaccination rates by continent, we see that North America and Europe have the most distribution. Asia is somewhat less. South America is a bit more, and Africa is particularly low. And Africa is an area or a continent that is surging right now. Greater than a quarter of the countries are surging, are detecting cases surging. Only 0.6% of the 1.3 billion people are fully vaccinated. And again, also due to more transmissible variants, the Delta variant. And what's being seen is something that I think is being seen in Indonesia right now, and that is that more young people are being infected. And again, the same problems are what we're seeing here, is that testing, vaccine supply and distribution, not as much viral genome sequencing, little economic stimulus to help people who during lockdowns, and also overwhelmed healthcare systems. I think just about every country has gone through this to some extent. Now, COVAX and doses supplied to Africa and other areas are in some ways directed by or handled by COVAX. So COVAX is a mechanism by the World Health Organization, Gavi, or the Global Alliance for Vaccines and Immunization, and CEPI, the Coalition for Epidemic Preparedness Innovations, to ensure equitable access of vaccines around the world. And their goal is to have 2 billion doses available by the end of 2021. And just within the last week and a half at the G7 meeting, the G7 countries said that they would extend 1 billion vaccine doses for poorer nations. So to get an idea, we saw it in it graphically, but let's take a look in the map, vaccination, the doses administered by country. And you see that, so the darker green means more vaccine doses, and the scale is shown at the top. So you see that North America is probably among one of the top vaccinated, as is China, certain countries in the Middle East and in Europe, some countries in South America, but there are other countries that desperately need more vaccination and more distribution of vaccines to thwart the pandemic. And these are areas that where we're seeing the spike in cases, where there just hasn't been access to vaccines or distribution of vaccines. So when we talk about the different types of vaccines available, we'll talk today about some of the major ones that are available, but keep in mind that vaccines are continuously being generated and tested. And so there's more in the pipeline. But at this point, you can really sort of look at it as four different categories. The vaccine, I think that's popular or that's being used quite a bit in Indonesia is Sinovac. Sinovac is an inactivated virus vaccine. And so that is, the Chinese offer at least 7 vaccines. 5 of those are inactivated virus. Protein subunit vaccines like Novavax. So that's actually pieces, protein subunits, generally spike from the SARS-CoV-2. Other ones, including the Oxford AstraZeneca, the Janssen or Johnson Johnson, and the Gamaleya in CanSino, are adenoviral vector. So using an adenoviral vector to bring in and express an infected cells piece of spike. And then also the mRNA encapsulated in lipid coats. So they're basically the nucleic acid vaccines, basically Pfizer, BioNTech, and Moderna vaccines. And basically they target muscle cells, where in terms of the Moderna or the adenoviral vector, the subunits are expressed, released, and the key cell, of course, is the antigen presenting cell here, which then through T helper cells leads to both hopefully a T cell response, and there's been evidence to that from many of the vaccines, as well as a humoral response, an antibody response that will generate antibodies, and hopefully long-lived T cells and B cells that recognize hopefully for months to years, to protecting it from future infections and protection from, hopefully protection from variants. So what I wanted to show you just very quickly is just, and I think it's a real testament to the importance of biomedical research, and that is how quickly the technology for mRNA vaccines has transpired, from all the way from the discovery of mRNA in 1961 all the way to the present time. So the green boxes show key advances in either mRNA biology or how it's been developed and to be used as vaccines. And then in the blue boxes are key changes that have occurred, or key advances in the development of mRNA drug packaging materials. In other words, how to introduce the mRNA vaccine and to formulate it as a drug. And so what you find is that if one goes through here, I won't go through in depth, what you'll find is that really mRNA as vaccines, they were initially used as anti-cancer vaccines, but now have been developed for various infectious disease. A lot of the major work, a lot of the advances have happened just in the last 25 years. So I find that really remarkable. mRNA vaccines are also, there are a lot of studies, primarily phase 1 and phase 2 studies, of using these mRNA vaccines against various cancers, as well as several infectious diseases, clearly SARS-CoV-2, but also influenza, rabies, Zika, CMV, and HIV. And then the other thing that it's nice that the mRNA vaccine platform offers is the ability to be rapidly modified and for responding to variants, i.e. in the case of, say, booster shots. This is a very busy chart, unfortunately, but it does give you an idea of an overview of some of the major vaccines. So we have the Pfizer and the Moderna vaccines, mRNA. They're generally 2 doses, 21 and 28 days apart. Overall efficacy is 95 to 94%. And there's recent data suggests that this efficacy extends, maybe slightly decreased, but not much to the variants. But the key with vaccines, and I think this is the key with the majority of the vaccines, is that they prevent severe infection. They tend to greatly decrease hospitalizations for severe infection, and they largely prevent death. And so people may still get sick, but they don't get as sick, and they don't necessarily need to end up in the hospital. They don't end up on ventilators, and they don't die. And so that's the real benefit of vaccines pretty much across the spectrum. The problem, of course, with the Pfizer and the Moderna vaccines is that they need to be kept at deeply sub-zero temperatures. So this is difficult to reach out to certain regions that don't have access to this. The AstraZeneca vaccine we'll show is very widely distributed. It's a chimpanzee adenovirus. Also 2 doses, 28 days apart. Very, not as high as the mRNA vaccines, but very high efficacy. Again, protection against severe infection, 100%. The benefit to this is that they can be stored at 2 to 8 degrees and last at least 6 months. The Janssen or Johnson & Johnson vaccine, the human adenovirus serotype 26. This is also an adenoviral vector. It is just 1 dose. So that's made it very useful in areas where 1 dose is easier to distribute. It was a lower overall efficacy, but again, very high protection against severe infection and death. Long-term storage also sub-zero, but at least 3 months. This was stopped, at least in the United States, for a while because of this syndrome, thrombosis and thrombocytopenia syndrome. But it was deemed that it was a very rare event, and so I think this is being redistributed now. The Gamaleya is one that produced in Russia, and so it's been in that part of the world and sent to other countries. We'll see how many in a moment. So Russia, 2 doses, 21 days apart, reportedly high efficacy, 100% affection against severe disease, but also needs to be at sub-zero temperatures. Some very recent data came out on the Novavax vaccine. So this is a recombinant S protein nanoparticle plus with a matrix and an adjuvant. This one's 2 doses, 21 days apart, high efficacy, 100% protection against severe infection. And the nice thing is it can be stored at 2 to 8 degrees. Actually, some data just came in saying that this number is about right, about 90%. Now, China uses, China uses, as I said, 7 vaccines. 5 are inactivated virus. So there's the Sinovac, or made by the company Sinovac, and the name of the vaccine is Coronavac. It's an activated virus. I've seen different numbers, but from what I can piece together, it's about 51 to 78% effective against infections, around 98% against death, preventing death. It's WHO approved, 2 doses, and the nice thing, can be stored at refrigeration temperatures. Sinopharm is an inactivated virus. Efficacy of about 79% against both symptomatic infection and hospitalization. So again, the value of the vaccines is that you still may get sick, but you're not ending up in the hospital, and you're largely prevented from death. It was WHO approved. There's been some concern about breakthrough cases in some areas. The Seychelles is one, so that's still being investigated. There are 2 doses also, also storage at refrigeration temperatures. And then there's another vaccine, the CanSino vaccine, now this one differs from some of the other Chinese vaccines. It's adenoviral type 5 vector. Efficacy is not super high, but it's 66% for symptomatic disease, 91% against severe disease. So there's value there. There was some recent data suggesting there's waning immunity after about 6 months. So what they're thinking now, and many researchers are looking at this, is potentially using this as a booster for patients or for people who were previously vaccinated with an inactivated virus vaccine. It's 1 dose, again, storage at 2 to 8 degrees or refrigeration temperatures. In India, we're familiar with the horror that has gone through India with cases and deaths. They're one of their major vaccines, and I think they use at least 3, but one of the major ones is Covaxin, Bharat Biotech. It's inactivated virus, efficacy about 78%, but again, 100% against severe infection. There is some evidence that it's active against the B.1.617 variant. Now, this has actually been broken down. So the actual Delta variant is actually B.1.617.2 based on specific mutations. But nevertheless, there does seem to be some activity. There, again, 2 doses and refrigeration temperature. So just as an overview here, skip myself over there. Let's just look at this in terms of how these vaccines compare in terms of how easily they can be used. We saw the RNA vaccines, very high efficacy, but they need sub-zero temperatures for storage. The viral vector, the Oxford AstraZeneca, the Sputnik or the Gamaleya, and the Johnson & Johnson or Janssen vaccines, these each need 2 doses. The Johnson & Johnson just 1, 2 to 8 degrees for the Oxford, sub-zero for the Gamaleya, and 2 to 8 degrees for the Johnson & Johnson. For the Sinovac, 2 doses, but it can be stored at 2 to 8 degrees. Sinopharm, same thing, 2 doses, 2 to 8 degrees. Covaxin, one major one in India, 2 doses, 2 to 8 degrees. And the Novavax, 2 doses, also 2 to 8 degrees. So let's see how each of these vaccines is distributed in various countries. And what we're looking at is the Oxford AstraZeneca is actually distributed presently in about 177 countries, as indicated by the dark green, pretty much very wide. The Pfizer is also widely distributed, predominantly in the Americas, but also in Europe and certain countries in Africa, the Middle East, and Australia. Sinopharm is very rich in Asia, in China, in certain parts of Africa and South America. The Moderna or the other mRNA vaccine, largely in the Americas and in Europe right now. Gamaleya is, again, as I mentioned, largely in Russia and certain other parts of Asia and Africa, South America, and Central America. Sinovac, very rich in Asia, very widely distributed in Asia, and some in Africa and South America and Mexico. The Johnson & Johnson or the Janssen vaccine is in 24 countries, largely in the United States at this point, and Europe. The Covaxin, clearly in India, and about 5 other countries. CanSino, which is the one I mentioned that could be used potentially as a booster at some point, also richly in Asia. Let's see. And then I just want to mention some other vaccines, just for the sake of completeness, that are only distributed in 1 or 2 countries, but they're interesting. The Sinopharm WIBP is also an inactivated virus. It's just used now in China and the United Arab Emirates. The Epivac Corona is a peptide vaccine and really just found in Russia and Turkmenistan. The Abdala, which is a subunit vaccine, and the Soberana 2, which is a conjugate vaccine. So it's not one of those 4 major types. It's spike protein conjugated to an activated tetanus toxin, which is a strong immunogen. And these 2 are actually used in Cuba. So the Abdala and the Soberana 2 are used in Cuba. Casvac, which is an inactivated virus, and the other inactivated virus, which is a derivative, which is from Sinopharm, made by Hyattvax, is used in, is Hyattvax, is used in Kazakhstan. And then the RBD dimer is a subunit vaccine used in China and Uzbekistan. So those are the major vaccines that are presently being used and have been approved in various countries. So I want to use this slide as a case in point, in this case, the United Kingdom, but I think it's applicable to every country, every region. And in the UK, and so here we're looking at new confirmed COVID-19 cases, and this is the United Kingdom, and then the new confirmed COVID-19 deaths. And the key here is that in the UK, the Delta variant has become dominant. However, vaccination rates are high, so there's been no increase in deaths. In the US, the problem has the decrease in cases that we had seen with the rollout of vaccination has somewhat plateaued. And the reason for that, and some of that is due to vaccine hesitancy, some of it is inequality in terms of distribution of the vaccines to certain parts of the country. There are socio-political reasons where there's sort of more vaccine hesitancy, where certain states in the United States have not been adequately vaccinated. And then the concern is that along with that vaccine hesitancy, the spread of the Delta variant, which is already within the United States, as we'll see, as more and more of cities reopen, and also with the coming of fall and seasonality, the concern is that even in the United States, there could be more severe cases and deaths if the vaccination rate doesn't improve. And so what we see here, and the reason I wanted to show this, is even though the United Kingdom has actually seen a spike in cases that actually caused them to delay their reopening, you're not seeing an increase in deaths. So again, this underlines the importance of vaccination. So the important points from this part of the talk is that the major vaccines that are available now really are four major types. There's the nucleic acid, adenoviral vector, the inactivated virus, the protein subunits, and they're all generally effective to various extents. And early data also suggests that many of these vaccines have activity against the major variants, particularly the Pfizer, Moderna, and AstraZeneca vaccines. That being said, in terms of Indonesia, I think clearly there's only about 8.1% of the population has only had one dose of vaccine, and only 4.4% are fully vaccinated. So the key is for Indonesia is to really push vaccination, because I think that'll be the key. Because what has been noticed is that among clinicians who are treating these patients, and the clinicians have been vaccinated in order to be able to treat the patients successfully so they don't get sick themselves. What they found is that even with the Sinovac vaccine, which is the predominant vaccine being used in Indonesia, what's happened is that even though these healthcare professionals have found that they may get sick, but it's generally mild disease. And so there is some belief that there is definitely a protective effect being offered or being brought about by the Sinovac vaccine. The key, and particularly as Indonesia's open up, I know Indonesia just had a holiday. The key is really to accelerate for Indonesia the rollout of vaccines. And again, this is an issue for all countries across the planet. The United States included, Europe, everywhere, and certainly in Africa and other parts in South America. The key is to get vaccines in people's arms. That is the key. More studies are being done to extend vaccination to children. In the US, children 12 years of age and older can receive the Pfizer vaccine. And I'm sure there are studies that will be trying to push that up even more. With the spread of variants, as well as concerns of waning immunity, the notion of booster vaccination doses is being assessed. So this is ongoing research. The notion, there is a thought that at some point, or even with next year or the next 6 months, 6 to 12 months, it may be like the influenza vaccine, where one needs to have a booster, a seasonal booster for COVID, and that vaccines may have to be, modified to address particularly dangerous variants. So, and again, as I said, the booster shots, could be tailored to target the specific variants, with the mRNA platform being particularly, beneficial for this approach. So again, the main point of the talk is this, that there's an ongoing race, and I think every country is facing this, between rate of vaccination, getting as many members of the population vaccinated, versus the spread of these highly transmissible variants. That is the key. And so the vaccination rate for success to occur, for the pandemic to be defeated, the vaccination rate has to outstrip the spread of these variants. So let's take a look at these variants. What are the variants that we're talking about here that are ones of concern? Now, if we go by the World Health Organization classification, I think they actually have two basic designations of variants that are concerning. Let's put it that way. And as you know, as many of you know, the WHO, mostly for ease of communication in the popular media, but not so much in scientific media, has changed their labeling to the Greek alphabet. And then so many of you are probably familiar with this nomenclature, the Pango lineage, where it was like B1427 or B1429 or P2, P3. B1617.1, which is another offshoot of the B1617, or the B1617-0.2 is the actual Delta variant. And then there's the GISAID or GISAID clade lineage. And so these are what are known as variants of interest. So this is a WHO classification. This is the variant of interest, or VOI, and there's presently 7 of them. So it's epsilon, zeta, eta, theta, iota, kappa, and lambda. And so the reason how that is designated is that a SARS-CoV isolate is a variant of interest, or VOI, if compared to the reference isolate, its genome has mutations with established or suspected phenotypic implications in either one, it causes community transmission or multiple COVID-19 cases clusters, or has been detected in multiple countries, or is otherwise assessed to be a VOI by the WHO in consultation with the WHO SARS-CoV virus evolution working group. So these are ones that have not risen to the highest level of worry, but these are 7 that are being watched. The other designation only has 4 in it, and these are the variants of concern. These are the variants that are causing the most worry and are probably doing the most damage across the planet. In a moment, we'll see how these are distributed across the planet. So this is very simple, and I think everybody in this audience is familiar with this. These are the alpha, beta, gamma, and deltas. People have known them as respectively B117, B1351, P1, and now B1617.2. So this is alpha is the United Kingdom, that was known as the UK strain. The beta was in South Africa, the gamma was first detected in Brazil, and the delta in India. So a VOC meets the criteria for a VOI, plus one or more of the features below relevant to global public health, which is an increase in transmissibility or detrimental change in COVID-19 epidemiology, or an increase in virulence or change in clinical disease presentation, or a decrease in effectiveness of public health and social measures, or available diagnostic, vaccines, or therapeutics. So it may thwart either treatments or a vaccine or post-convalescent serum response. So let's look at these individually, these 4 variants of concern. So the first is the alpha. This was previously, or is also designated B117. Or the United Kingdom variant is now known, it's also known now and referred to in the media as alpha. What you can see is that it's very widely distributed all over the planet. Some of the main features are around 50% increased transmission. So again, higher transmissibility. There's a potential increased severity. So this strain seems to be more severe in its presentation, or there's some evidence for that. It seems to it's not seeming to be particularly more resistant to certain of the emergency use authorization monoclonal antibody treatments. and it doesn't seem to be particularly resistant to either convalescent or post-vaccination sera. So to understand the key mutations, and keep in mind that these variants, it's good to keep in mind that the receptor binding domain of the S1 subunit of spike consists largely of amino acids 319 to 541, and these are the mutations within this region are the ones that are provoking the most interest. So I think you might remember maybe half a year ago, or more actually, 8 months ago, when D614G first came out. Well, and that was concerning because it seemed to induce a conformational change that seemed to make it, in some way, it seemed to increase transmissibility. Well, D614G is worldwide now, and it's included in basically all of the VOCs, certainly alpha, beta, and gamma, and I'm assuming also in delta. So the main mutation is the N501Y. N501Y seems to enhance binding of spike to the host cell through binding to ACE2 receptor, but it also has some other interesting mutations. And one of that is this P681H. It's worth noting that there's a furin cleavage site between amino acids 681 to 685, or also known as the polybasic site, where that seems to assist with the cleavage of S1 and S2 that seems to facilitate increased uptake of the virus into the cell. So that's any mutations around that area are of interest. And so this is a side view of the trimer. You're looking at the spike trimer. I think the coloring here is a little unfortunate, but nevertheless, that would be the trimeric structure. And then if we're looking down on the spike, what we see is the position of the N501Y, which is right there in the binding region. So that's alpha. And then next is beta, or previously known as B1351, or previously also known as the South Africa variant. Also widely distributed, and these are verified locations. It has about a 50% increased transmission. It seems to show significant reduction in susceptibility to some of the approved monoclonal antibody therapies, but there are other monoclonal antibody therapies. And there's some indication that it has reduced neutralization by convalescent and post-vaccination sera. Now, this one has 3 mutations, which are largely conserved also with the next one we'll look at, gamma. And those are N501Y. And again, we're looking down on the top of spike here. So N501Y, which is the same mutation we saw in alpha. This is the very concerning mutation here, E484K. And then also K417N. So those 3 mutations are all in the receptor binding domain. E484K has been shown to be capable of some immune evasion. So it's decreased neutralization by some antibodies. And the K417 asparagine, and we'll see that in the gamma, that's the same mutation, but it's actually to a threonine, seems to assist with enhanced binding. Excuse me. So then the other one is gamma. You may know it as P1. It is also widely distributed throughout the Americas and certain other regions of the world, Europe, parts of Asia and India and Australia. It also has the same mutations as largely as beta, but as I said, it has N501Y. It has E484K, and instead of this being an asparagine, it's a threonine. And it shows significantly reduced susceptibility to certain of the monoclonal antibody therapies, and seems to show reduced neutralization by convalescent and post-vaccination sera. That being said, I mean, it's measurable, the decrease in the post-vaccination to the susceptibility to post-vaccination sera. But as we'll see, so far, most of the vaccines are still fairly active against the variants. I think we're still on some of the vaccines, and some of the vaccines from China, we're still waiting for final data on that, but I'm sure that data will be forthcoming. Finally, the newest one, the one that is just caused terror in India. It's B.16172, also known as Delta. Again, first detected in India, but also now widely distributed. It's I saw data. It's very well distributed in the UK and the United States. I know it is very well distributed also in Indonesia, and this is a concern among Indonesian clinicians at this point. It's attacking younger patients, making them sick. And again, the key to that will be to really to continue to vigorously roll out vaccination. Delta was initially, so it has increased transmissibility. There is a potential reduction in some of the responses to monoclonal antibody therapies, as well as a decreased reduction in neutralization by post-vaccination sera. So that's what's concerning. So this is very new. So as data is still coming in, we have some preliminary data that certain of the vaccines are effective against Delta, but for the other vaccines, that data still needs to be developed. This mutant was initially called the double mutant. Now, as we know, all of these variants, all the variants of concern have probably somewhere between 18 to 23, if not more, mutations throughout their genomes. But people have focused on the mutations in the receptor binding domain. So here, the main ones are L452, which is actually also seen in a variant in California in the United States, and E484, which is the one of greatest concern. So among those, so that's the fourth of the four variants of concern mentioned by the World Health Organization. And there's a great deal of concern given that how far Delta has already been spread across the planet. So important points for this part of the talk is that the World Health Organization has listed 4 variants of concern. We just discussed those: alpha, beta, gamma, delta, and at least 7 variants of interest. The VOCs each have their own set of dangerous characteristics that include increased transmissibility, resistance to certain monoclonal antibodies and or convalescent or post-vaccination sera, and potential increased clinical severity. That was certainly the case with alpha, and I think based on some of the presentations, that's also the case with delta, although that remains to be seen. What we've seen is that all the VOCs are widely distributed geographically. Though some mutations lead to immune evasion, most studies find that the vaccines remain effective. And this is for the vaccines where the data has come back. And as the physician that was quoted in what I was reading in Indonesia was saying is that that physician's colleagues, were only, who were treating patients with COVID-19 had largely mild disease. So, his impression was that Sinovac vaccine was offering a certain level of protection, which is great. Now, the major risk, and again, it comes down to what we said before, the major risk is the spread of highly transmissible variants through unvaccinated populations, which could lead to development of additional variants. I mean, that's the thing. It's the longer that the virus stays active and is moving among unvaccinated populations, the increased risk of variants, and the more cases and the more deaths and severe cases of COVID. So the key is to really accelerate vaccination in every country in the world. So in terms to summarize this part of the talk, though the pandemic is generally in retreat in wealthy countries, spikes in case numbers are still being seen. Severe cases and deaths are decreasing due largely to vaccines, particularly as countries open up. Nevertheless, in countries like the US, there's concern whether this notion of herd immunity can ever be attained. And that can only be attained if as many people as possible gets vaccinated. For example, in the United States, Dr. Fauci had suggested that herd immunity wouldn't be attainable till somewhere at least 70 to 85% of the population was vaccinated or had convalescent, was post-infection. And I think that number is probably being pushed more to 85%. The future of the pandemic in less wealthy countries is dependent on the ongoing race between vaccination and the spread of the more transmissible variants. And assistance to these countries is essential. So the value of the WHO, COVAX as part of the WHO effort, and the distribution of vaccines from countries that are the wealthier countries to the more developing countries is essential to really contain the pandemic. Though efficacy does vary, vaccines have proven themselves to be very effective in preventing severe COVID-19 cases and deaths. We're waiting for some additional data on some of those vaccines, but that seems to be the observational finding, is that these vaccines, and in some cases data-backed, for some of the vaccines, there's been data to definitely demonstrate that. The efficacy of vaccines against variants is being constantly assessed. And just now some data has come back, as I mentioned, for Pfizer, Moderna, and AstraZeneca in particular. The need for and the design of booster shots is currently being considered, though all the major vaccine platforms are flexible. The mRNA-based vaccines are most suited for rapid modification against new variants. But again, this can also occur with the other classes of vaccines also. So there is flexibility on the other platforms. The notion of vaccine schedules using different types of vaccine is being studied as a way to generate a more robust immune response. And the future of the areas of ongoing research and clinical concern include post-acute sequelae of SARS-CoV infection, also known as PASC, or long hauler syndrome. This has certainly been seen in the United States. I'm sure it's been seen all over the planet. And this basically reflects ongoing neuropsychiatric, neurological, cardiac, pulmonary symptoms that persist for at least 4 weeks after the start of symptoms. So the acute disease resolves, but people still have fatigue, they have shortness of breath, they have cognitive problems thinking, problems staying concentrated. And so I know in the United States, the NIH has just put $1 billion towards research of this, because this is something that's going to be an issue across the planet. Other areas of intense research that are needed are continued variant surveillance, the development of therapeutics to treat COVID cases, and there's some optimism that we may have some, anti-COVID pills, if you will, or medications by the end of the year. Ongoing understanding of coronavirus biology is very important. This is now the third coronavirus that's deadly coronavirus that's occurred on the planet in the last less than 20 years. This is very unlikely to be the last. And then, of course, ongoing research and ongoing development of vaccines. So at this point, that's that part of the talk. I just wanted to quickly go through some of the SARS-CoV-2 reagents that are available from GeneTex. And so if you're able to stay, I'll try to wrap that up within the next 10 minutes or so. But I just wanted to give you an overview of what our catalog is for this, for SARS-CoV-2. GeneTex has really made a commitment to try to have the leading and the most comprehensive catalog of reagents for SARS-CoV-2, as well as other coronaviruses, including SARS and MERS, as a subset of our catalog against other pathogens, predominantly viruses. So just as we have conventional and recombinant rabbit monoclonal antibodies against spike and nucleic capsid, rabbit polyclonal and mouse monoclonal antibodies against various SARS-CoV-2 non-structural and accessory proteins, antibody pairs, verified antibody pairs for ELISA and lateral flow assay, an increasing a number of recombinant proteins for various like the structural proteins, one of the key enzymes, NSP5, humanase 2 and this is just a subset of what we have, but also we're developing, and we have at this point, recombinant proteins for the major variants. The Delta variant is being developed now. We also have cell pellet blocks for IHC controls and overexpression lysates, and a nucleic capsid protein sandwich ELISA kit, which is quite sensitive. This is a busy slide, but all I want to say, we have at least 24 total antibodies against spike. 14 of those are recombinant antibodies, so rabbit recombinant monoclonal antibodies. For nucleic capsid, there are at least 15 total antibodies. 10 of those are recombinant. And many of these spike and nucleic capsid antibodies are validated for a range of applications. We've also generated several antibodies against the directly against the receptor binding domain, at least 12 of those, and 8 of those have some neutralization activity, including this one, which seems to block the interaction between the RBDs of the alpha, beta, and gamma mutants with ACE2. And then we also have, very importantly, I think, which will be very useful, I think, as research moves forward, at least 6 antibodies, 3 spike antibodies and 3 nucleic capsid antibodies that have been validated for immunohistochemistry on infected tissue samples. One of these is GTX-632604. It's a mouse monoclonal antibody. I think it's the most highly cited antibody for SARS-CoV-2 research directed against the virus. It has probably by now more than 70 citations for multiple applications. We also have at least 5 antibodies, including 632604, that have been validated for flow and FACS. As I said, is in the push to really generate a comprehensive catalog of antibodies. We're also trying to get as many antibodies as we can against the various non-structural proteins. As more and more people do the molecular biology, looking at these at the functions of these proteins in the pathogenesis of SARS-CoV-2. And so we have several here and more are in development at the present time. We also, as I said, mentioned a very sensitive nucleic capsid protein sandwich ELISA kit. And then, as I said, a SARS-CoV-2 recombinant proteins that includes in the format of, like spike S1 for the various, and these are the variants of concern. So B1, so alpha, this would be beta, this would be gamma. And so for researchers who are interested in doing in vitro work with the different RBDs or different S1 proteins bearing these key mutations, those are available also. And this extends to also S2, nucleic capsid protein, envelope protein, and the NSP5 protein, as I mentioned previously. And then actually specific, just the RBDs of these mutations. So again, for the alpha, for beta, and gamma. And as I said, the Delta variant is in production now. These are just an overview of all the mutations that happen in each of the alpha, beta, and gamma alpha, beta, and gamma variants. And then we also have overexpression lysates for some work. We also have formalin-fixed paraffin embedded cell pellet blocks that can be used as IHC controls. Matched ELISA and lateral flow assay pairs, and so these are all listed in the catalog. And then some associated products, including antibodies against ACE2, the recombinant protein, an antibody against TMPRSS2, which is a co-receptor and is involved in uptake of the virus into the cell, and then camostat mesylate, which is actually an inhibitor of the TMPRSS2 serine protease. And with that, I'd like to say thank you very much for your attention on a Saturday morning. I hope you can enjoy the rest of your day. And thank you very much.
Thank you so much, Dr. Alex, for your presentation. All I can say that was a great presentation, and we hope that we can use the information that you have and the one that you shared to be able to build also our research here back in our country.
Right.
So we will get back to you on Q&A session while we're going to continue our webinars. Setelah menyimak presentasi dari Dr. Alex, sudah kita lihat ada beberapa peserta yang ingin bertanya mengenai topik yang dibawakan pada pagi hari ini. Dan kami akan kembali, bagi yang masih memiliki pertanyaan, kami persilahkan untuk menuliskannya di kolom Q&A. Dan juga Bagi peserta yang belum mengisi link presensi dan feedback form, dapat melakukannya melalui link yang sudah dibagikan di kolom chat. Karena pada akhir acara ini, kami akan membagikan hadiah menarik untuk 12 orang yang beruntung. Sebelum kita melanjutkan ke sesi tanya-jawab, sesi berikut kita simak terlebih dahulu company profile dari PT Biozatik Indonesia. Dan sampailah kita di sesi tanya-jawab. Di sesi tanya-jawab ini, kami sudah mendapatkan beberapa pertanyaan dari para peserta. Pertanyaan pertama datang dari Saudara Prisma Wirianti. Hi, Alex.
Yes.
I will translate it for you.
Okay.
How long vaccine can prevent someone from getting infected? Is it 3 months, 6 months, or 9 months, or even a lifetime?
What's that? I'm sorry. Could you repeat the question? I'm so sorry.
So how long vaccine can prevent someone from getting infected?
Right. Yes.
Yeah.
So, yes, that's a good question. And I think that's still being, I mean, remember vaccination has only been really going on for at most the last, 7 months at most. So it's still unclear. There's some indication, as I said, for like the CanSino that the immunity may wane. I think this is still being determined. There's been some indication that several of the vaccines are actually able to induce a T cell response. So the key is, and I think that's still being determined, is whether boosters will be needed every, not maybe 6 months, but on a yearly basis to boost vaccines. And I think that still remains to be seen. So I'm not sure I have a really good answer on that yet. That is something that will have to be followed.
Okay, thank you so much for your answer. And for the second question is that if using adenovirus, will it generate a host immunity against the adenovirus and can decrease vaccine efficacy if a vaccine using adenovirus vectors?
Right. So I think if I understand the question, what you're asking, or what the researcher is asking, is whether the adenoviral vector invokes its own immune response, and I think that's why they're very carefully chosen for certain types of adenoviral vaccine, and that's why they're used to minimize any sort of immune response against the adenovirus itself. That's my understanding.
Okay, and can it decrease vaccine efficacy?
Sorry?
And can it decrease vaccine efficacy?
Oh, that's a good question. I mean, I think overall, the adenoviral the adenoviral-based vaccines are not as high as the mRNA vaccines are. I think there'll be some additional data on that. But overall, the numbers that at least I have seen, and keep in mind these efficacy numbers can vary depending on, because there's studies done in different countries and different groups, and so it's hard to say. But on average, it's slightly decreased, but they're still very effective. And I think that there's been some very promising data with the AstraZeneca vaccine that it has wide-ranging efficacy. So in other words, it doesn't have to be 90%. You know, if it's 70 or 80, that might be good enough. You know what I mean? But it may need a booster at some point, and all the vaccines may need boosters. I mean, that still remains to be seen.
Okay, and we're going to go to the third question. If we already take Sinovac vaccine, can we take another kind of vaccine, and is it safe?
Wow, that's a good question. I think there are people who know much more about that than me. I mean, I think, again, I cite the example of the CanSino, how they think the CanSino vaccine can be used, which I think is, as I remember, is an inactivated, is a adenoviral vector vaccine. And that could be used in areas they're thinking where largely inactivated virus vaccines have been used. And so I think that remains to be seen. So that is being discussed, you know, the possibility of using different vaccines for different, but in terms of safety, I would have to look that up to see if there's been any indication that, but it has been discussed about using different types of vaccines.
Yeah, thank you so much. And another question from Maulidiani Abu, and if it is safe to take different vaccine, how long will it take to be able to use the other vaccines?
Yeah, that's again, you know, I think these are very important questions, and I don't think I have a good answer for them because I think that's still being looked at. I think the necessity for, I mean, the only reason I mentioned the CanSino vaccine is just because the papers that I saw had indicated that as used as an initial vaccine, the immunity seemed to wane after about 6 months. And so it was also being used as a possibility as a booster. And so, but in terms of mixing and matching different vaccines, I think that is still being looked at. I'm not aware of a lot of studies that have really examined that in terms of, in addition to safety protocols, because I think we're still trying to get people vaccinated the first time, you know? So, yeah.
Yeah. Okay, thank you so much for your answer. And the fourth question is coming from Ima F. Harahap, and it's cases where autoimmune patients who were under control under her daily treatment, right? There is a patient, autoimmune patients, who were under control under her daily treatment, and after the first vaccine, her symptoms started to appear mildly for 24 hours and then disappeared. However, after the second vaccine, on the same day, her symptoms, which under control for 1 year, starts to appear. And to overcome this, her daily dose treatment needs to be increased. Do you get it until now?
Yeah, that sounds like a very, so if I understand correctly, there is some concern that her autoimmune disorder, the symptoms are being exacerbated by the vaccine.
Exactly. Yeah, that's the case. And
yeah.
So the concern is it safe for the autoimmune patients whose symptoms are under control to take the vaccination of SARS-CoV-2? Is it safe for the autoimmune patients?
Well, I have to say I would have to look at that more closely and study more papers to give a safe answer, since this is involving a patient's care. So, you know, if you give me the contact information, I can get back to that physician or that clinician.
Yes, sure.
And get back to that person. But I think that's a very difficult question. And I think there are probably people who are more qualified. I mean, I think that is something that would probably be best directed to a rheumatologist.
Yes, and also
specifically
immunology.
somebody. Yeah, and right, an immunologist.
Yeah, immunology.
And that's not necessarily, that's not my background, so I don't feel comfortable giving patient. That's really wasn't the point of this talk. Was just sort of an overview. In terms of specific patient care, I think it's best to talk to immunologists and potentially a rheumatologist on that, particularly as they manage autoimmune disease.
And we will choose one last question. So the question is coming from Sunarto Ang. How about effectiveness of the Sinovac and Sinopharm vaccine to prevent SARS-CoV-2, B.1.617 Delta or Delta? Thank you. So how about the effectiveness of the Sinovac and Sinopharm vaccine to prevent the SARS-CoV-2 Delta mutation?
So how effective is the Sinovac vaccine against the Delta variant? Is that correct?
The Delta variant, yeah.
I think that's an evolving question also. I'm not sure that data has been released, to be honest with you, given the newness of the Delta. And I think for some of the vaccines, we're still waiting for some of that data. Again, I can quote, in a report that I read, that physicians on the ground seem to feel that their colleagues were seeing just mild disease instead of more severe disease. So at least anecdotally, it seems like Sinovac has some activity at least against Delta, but I'm not sure that I've seen how a quantitative measure of the effectiveness of a Sinovac vaccine against Delta. I think clearly I know there'll be a lot of data that comes from what's happening with Indonesia now, and certainly will come out. And so I think that will be very valuable to see.
Yeah, there is a lot of question here, but we are going to answer one last question. It's from Ryan, that he asked that about something that's bothering him. And we know that mutation happened in SARS-CoV-2 and spread from human to human. And there are a lot of mutations and variations also detected which had been presented by you. So is there any chances that the mutation will infect animals and make them suffer in their respiratory system like us? Is there any?
You mean transmission from humans to animals?
Transmission from human to animals, yeah.
Well, I guess that's possible. I don't know. You know, it's interesting because one would, you know, there was always the concern of whether, you know, the virus could be transmitted, say, from, you know, pets, you know, to humans.
Yeah.
But I'm not entirely sure that, you know, it can go. I mean, I haven't seen any data on that, whether pets can be infected by, you know, or animals can be infected from humans. I mean, clearly, you know, when they look at, you know, intermediate animals, and for some time they thought it was pangolins because of the high level of sequence identity between SARS-CoV-2 receptor binding domain and what was seen in pangolins. I'm not sure if people are still looking at that. But, you know, from humans to animals, yeah, I'm not familiar with data on that, to be honest.
Oh, okay. But do you think it's possible, or you
yeah,
have
not... I mean, again, everything, you know, you want to always imagine that it's possible. But I'm not sure how likely it is, you know, going from humans to animals. So, you know, I haven't heard any, you know, certainly the notion of that, say, if you're sick with COVID, that if you have an animal that you care about, or an animal like a pet or something, that you shouldn't be exposed to the animal. I'm not really sure I've ever seen those kinds of studies, but I imagine as long as the virus, the animal expresses ACE2, like an example would be, a mouse. Mice aren't particularly susceptible. I mean, to do the studies, you actually have to put in the human ACE2, receptor. You have to do genetic. So I think it's probably on a species by species basis, but that's speculation.
Okay. And is it okay if we are going to answer one last question?
Sure.
Alex? And one last question from Fitri Rohmasari. Can herd immunity be achieved if the virus keeps mutating?
I'm sorry, once again, I'm so sorry.
Can herd immunity be achieved if the virus keeps mutating?
Well, this is an excellent question. This is an excellent question. And, this is, and again, I will use the United States as an example. The concern is that as the virus goes among unvaccinated portions of the population, you do worry about new variants coming out. I mean, the goal is to basically to eradicate the virus as quickly as possible before it has a chance to mutate. And as it stands now, the vaccine, the virus, as it mutates, it will be, the vast majority of neutralizing antibodies that have been characterized are against the receptor binding domain. That's been shown. And so the concern is that, so that's why mutations in the receptor binding domain are sort of what people focus on and that type of thing, right? So the goal, though, it is going to continue to mutate, but the best way to put that down is to spread vaccination. So I think that by and large, the general notion for all the vaccines is that they are active against, for the majority of the vaccines and the data that's coming back that we have is that they're largely active. They're still active against the variants. It may decrease, but even if it's slightly decreased, the key is if enough people are vaccinated, that variant won't really have any place to go and it'll peter out. And that's the hope. The problem is unvaccinated populations. That is, and then so the vaccines in general have protective capacity, probably against most of, if not all the variants, most of the variants. The key is to just get people vaccinated. So in answer to the question, I think the answer to dealing with variants is to get as many people vaccinated with the vaccines we have now, and then to reassess the need and to follow out and to be and to check and follow and to do the studies necessary to see if that immunity wanes, and that if new variants come out, to develop booster shots to rebuild that immunity, particularly and certainly in the case of most easily the mRNA vaccines, to develop vaccines against targeting specific variants, and then rapidly disseminate that in a booster format. So again, the level of vaccination goes up. And at that point, you can hopefully approach the notion of herd immunity. Herd immunity, I'm not sure the issue is really, I think it's more economic inequality and socio-political and economic issues that are really the major blockages or the major impediments to getting herd immunity. I'm not sure I don't think it's the vaccines. I think if we got 85-90% of the planet vaccinated, we wouldn't be having so much concern about variants. That's really the goal. That's how I would answer that.
Okay. Yeah, thank you so much for your answer, Dr. Alex. And I think we will end the Q&A session on this point, and we will get back to our webinars. Thank you so much.
So, yes, and please share my, if anybody has questions or wants a better answer,
yeah, sure.
They can please contact me. I think Ying has my contact information, and I can maybe direct people to papers, particularly papers that would help the clinicians with patients.
Yeah, thank you so much, Dr. Eric, for your help.
Again,
Yeah.
thank you for your opportunity.
So, sampailah kita di sesi tanya. Sebelum kami mengakhiri acara ini, kami mengucapkan terima kasih kepada atas antusiasme dari para peserta yang sudah mengajukan pertanyaannya, dan kami juga memohon maaf kepada para peserta yang pertanyaannya belum bisa dijawab. Dan sebelum kami mengakhiri acara ini, kami akan mengundi 12 orang yang beruntung untuk mendapatkan 2 buah antibodi dari Gentex, serta 10 hadiah menarik lainnya. Dan tanpa basi-basi lagi, mari kita putar undiannya. Dan pemenang yang pertama adalah Dr. Lutfi Wijayanto. Dan untuk pemenang yang beruntung kedua, mari kita putar undiannya. Adalah Melati Esther Sikome, STTK. Selamat kepada Dr. Melati. Dan yang ketiga adalah Megawati MTes. Selamat kepada Dr. Anna. Yang keempat adalah dan yang terakhir adalah selamat kepada Dr. Johari. Dan yang keenam adalah STMSI. Selamat kepada Ibu Eli. Dan yang ketujuh, selamat kepada Dr. Sari. Benny Kristanto. Selamat kepada Dr. Benny. Selamat kepada Dr. Sarah. Selamat kepada Dr. Losi. Ya, selamat kepada Dr. Ahmad. Dan ini adalah pemenang terakhir kita yang ke-12. Mari kita putar undiannya. mengucapkan selamat kepada 12 peserta yang beruntung dan kepada semua audiens yang sudah mengikuti webinar ini sampai akhir. Sekali lagi kepada peserta, dimohon untuk mengisi daftar hadir serta feedback form melalui link yang sudah dikirimkan di kolom chat maupun scan barcode yang terdapat di layar agar bisa mendapatkan e-sertifikat. Dan bagi yang kurang beruntung, jangan sedih karena akan ada hadiah-hadiah menarik lainnya di acara webinar kami yang selanjutnya. Dan kami, PT Biozatik Indonesia, serta Jintek, berterima kasih banyak kepada semua peserta yang sudah mengikuti webinar ini. Semoga webinar ini dapat memicu ide, gagasan, serta pemahaman baru yang dapat mendukung perkembangan riset tentang COVID-19 di Indonesia. Dan jika ada kebutuhan penelitian maupun konsultasi, bisa menghubungi CS kami. Saya mewakili Biozatik dan Jintek memohon maaf apabila terdapat ucapan yang kurang berkenan. Once again, thank you so much, Dr. Alex, for sharing your experiences and knowledge with us. It was such a pleasure for us to be able to deeply understand and to hear more about this topic.
Thank you so much again for hosting me. I greatly appreciate it.
Thank you so much for spending your Saturday with us. I hope that we can see each other again on another occasion.
Thank you.
Sekian webinar kali ini. Sampai jumpa di webinar menarik lainnya dari PT Biozatik Indonesia. Salam sehat selalu dari kami untuk Anda dan keluarga. Bye-bye.